edge of each wing when it was lowered. The compressed air would act to lift the aircraft and help propel it 3 times the speed of sound. The design was given the name Xb-70, and SAC approved it for development in December 1957. North American had a long string of successes, including the development of the twin-engine supersonic Vigilante bomber for the U.S. Navy. This aircraft combined speed and bombing capacity never previously available to carriers. But now, having put forward the compression lift concept for a high-speed bomber, North American's big problem was heat. Wind tunnel tests proved that the theory could work, but the great speeds the plane would fly at would produce such heat that all conventional materials would warp. To tackle the problem, North American employed a honeycomb sandwich material made from stainless steel. This offered strength and dissipated heat. After 12 months of testing designs and mock-ups, an order was placed for 1 Xb-70. But the aircraft, now called Valkyrie, was in for a stormy time. 2 years after accepting the concept, financial pressures forced the Air Force to limit the production to 1 prototype. Although extra money was made available in 1960, the Air Force was having trouble holding on to its supersonic bomber. The final blow came with the arrival of Secretary of Defense Robert McNamara, who redefined the Xb-70 as a high-speed research project and limited production to just 2 aircraft. But at least the concept was still alive, and its proponents hoped it still might ultimately be accepted for military use. By 1963, at least 1 aircraft was well underway. The first Xb-70, serial number 20001, must have been an awe-inspiring sight for those lucky enough to see it. But it was not until May 11, 1964, that the press and public were given their chance to marvel over North American's sleek white wonder. Brigadier General Fred J. Ascani, who directed the B-70 System Program Office, described the plane's various features.
Most of the structure in the wings and fuselage is of stainless steel. These are our now famous honeycomb core sandwich panels, and many of the outer skins on these honeycomb panels are as thin as 7/1000ths of an inch. The 2-man crew will sit side by side. The crew station in this position is about 20 feet above the ground. All of the space aft of the crew compartment is taken up by fuel, both in the fuselage and in the wings.
Before the Xb-70 was poised at the downwind end of Palmdale's 12,000-foot runway for its first flight, numerous ground tests would have to be performed. Shortly after its debut to the public, the aircraft was again up on jacks, while its electrical and hydraulic support systems were thoroughly tested. All moving surfaces were subjected to vigorous testing. All flight controls, including the forward canards, the elevons, and rudders, were fail-tested and tested again. Like so much of the Xb-70, the landing gear, which had to support the plane's phenomenal weight, as well as the added stress of landing and takeoff, was, for the time, a unique and brilliantly designed feature. The forward twin wheels were conventional, but the support gear was required to rotate as well as fold the four-wheel bogie mechanism, which was stored in the limited space available. The whole process of extending or retracting the clever but complex gear could be achieved in a little over 20 seconds. All of the many complex tests that took place during the weeks before the first takeoff were recorded in a special flight test instrumentation package. A self-contained airborne unit, this device was the first of its kind. It was carried in the aircraft's bomb bay and remained with the plane for ground taxiing and in-flight tests. The Xb-70 prototype was also subjected to vibration tests that were designed to expose the gigantic fuselage and wing surfaces to the effects of vibration far beyond the point it might encounter in flight. As the aircraft tests proceeded, air crews were introduced to some of the engine's characteristics. Here, at the Arnold Engineering Development Center in Tennessee, a YJ-93 engine was set up in a simulation of the Valkyrie. The engine was installed in a test chamber to give the flight crew their first experience with its enormous power. The conditions were artificial, but similar to what the crew would experience in flight. Seen here is Al White, North American's chief test pilot, the man chosen to command the Xb-70's maiden flight. With him is Air Force Colonel Joe Cotton, the co-pilot for much of the early test program. The backup crew shown here are Van Shepard from North American and Lieutenant Colonel Fitzhugh Fulton. For months, these men were embroiled in the business of learning how to fly the world's most advanced and ambitious aviation project. By early September, most of the exhausting static tests had been completed. Now the most revealing tests would begin. Tests with the aircraft in motion. Then, eventually, tests of the Xb-70 in flight. Before the engines were fired up, the complicated in-flight recording systems were primed to record every technical event as it occurred. This view of the Valkyrie gives a clear picture of what became known as the six-pack. Tightly grouped together, this phenomenally powerful combination of 6 jet engines were to propel the Valkyrie to speeds considered impossible only a few years before. Now, hundreds of mechanical functions were checked. They would have to perform perfectly if the Valkyrie project was to succeed. The aircraft was removed from all external power sources.